Thanks for joining us again. Now we're introducing Eduard, who is our your cloud architect now, right?
Yes.
Right?
Yes.
Right. Yeah, our cloud architect and our cloud delivery team, and he's going to be discussing security in the cloud. So this is how we make sure our cloud delivery environment is secure, and our takeaways that you can take in your own environment. So thanks, Eduard.
Thank you, Mark David. Let's start, really. So what I want to talk about is really, even many of our clients are currently hosting on-prem, but they are thinking about hosting in the cloud, moving into the cloud, some or part of their operations, or they're already in the process of it. And even if you are already on-prem pretty secure, and you do lift and shift without any significant change on the overall scope and the view of your product, when you move into the cloud, your security posture changes, and at the very least, you need to reevaluate your security concerns. Some concerns will be eliminated by the move into the cloud, and on the other hand, you will have some new security surface which you need to protect. And this session is really a generic overview of what changed, what you need to do to stay secure, and how InterSystems product can help you with that as a part of your cloud environment. So let's start. Oh, wait, sorry. Before I start, one note on terminology. I will be mainly using AWS terminology. For example, may accidentally say EC2 instead of virtual machine, but it's all the same between the three major cloud providers. If there is some difference, some crucial difference, I will try to point that out explicitly. If I'm not saying that, that means that there is either no differences in particular in this area, or it looks fairly similar with just some minor changes. And with that, let's start. So here's what we will be talking about. First, we'll start talking about security foundations, really the most important parts which are different between on-prem and the cloud. Then we'll talk about identity and access management, threat detection, infrastructure and data protection, and finally, application security. So let's move on to the security foundation. And when you're hosting on-prem, the question is, who is responsible is very simple, right? The answer to the question, who is responsible, is very simple. It's you, right? There is no one else. You're responsible for everything. You as in your organization, right? In the cloud, that changes. You're now working under a concept of shared responsibility. There is some layers of your stack which are managed by your cloud provider, some layers of a stack which are managed by you, and in the case you're providing a SaaS or probably PaaS service, some layers will be managed by your clients. This creates an additional responsibility where you need to know what your layers are, what cloud vendors' layers are, and what your clients' layers are of responsibility. The easy and very straightforward rule of thumb is, if you have access to something on a cloud platform, you're responsible for it. If there are some knobs you can turn, you're responsible for it. If you have no information about how some part works, like for example, let's say we're hosting in AWS, and I don't know which particular rack our servers are placed in. So I'm not responsible about it, and I don't know about it, right? If I know how to configure something, how to change something, that means I'm responsible for it. And as an example, if you have, for example, a virtual machine, you will not be pretty much responsible for the underlying hardware. It will be provided for you. You just select, but you're responsible for everything, starting from operating system and up. You need to patch your operating system, keep it up to date. Any libraries which you're using, you will also need to keep up to date, and so on. And the scope of your responsibility here changes based on the service you choose, which we will talk in more detail later. Governance and risk management is another security foundation, but that I hope is way more familiar. It's pretty much the same as on-prem. And depending on your industry, you'll probably want to comply with a variety of regulations and standards. Hopefully you already have a security governance framework. There are many of them, but all of them, what they have similar is that you first create a list of the security events which you do not want to happen. You rate each of them on a probability from impossible to every day. You rate each event on consequences from minor to catastrophical. And based on these two factors, you order your events from most probable and most high severity one down to least probable, least severe one, and start working your way, mitigating them from top to bottom. Account management. When you start working in cloud, your goal should be to manage everything centrally. That includes accounts, controls, services, and resources. And that will be an entire theme of this presentation, that anything you can do, anything you can automate, you should. Remember that everything is an API call away from you. And as an example, raise your hands, please. Who is familiar with S3? Awesome, I'm seeing a lot of hands here. Awesome. So this is a file storage, and in AWS, it is accessible by both HTTP and HTTPS APIs. And you can go, for example, bucket by bucket, and you can forbid HTTP access for each of your buckets individually. Or you can go, if you have an organization with a root account, you can go into root account and create a SCP which disallows insecure access to your bucket's any S3 action specifically forever. And any new bucket will also be immediately under this control. So anything you automate, you can also forget, right? If you say at the root level that creation unencrypted disks is forbidden, your problem with unencrypted drives has been solved, because no one will be able to create them now. Separate workloads using accounts. Account is a very strong boundary in a cloud, and I highly advise you to take advantage of that. Create bags of resources if possible. This is unfortunately not available in AWS, but if you work with our clouds, you can create bags of resources, meaning you can create an artificial boundary, which would be a bag, which contains resources of different types, and you can assign permissions and access to the bag itself, or keep the permissions inside of this bag. Unfortunately, can't do that in AWS, but you can do that in some other places. And secure account root users. Generally speaking, your root user should never do everyday work. Of course, you will have an administrator, and this administrator, this person will have root access, but they generally work under entirely different account and never be a root user unless they have to perform an action which can be only performed by a root user. Operating securely, and this part is more or less similar between on-prem and your in the cloud environment. Stay up to date with security threats, subscribe to security mail list for every software which you're using in your supply chain. Identify threats, prioritize mitigation using a threat model, which we just discussed previously. Reduce security management scope. Here's an interesting one. Let's say you have a VM. You're running VM in a cloud. You're responsible for patching OS, patching software inside of the VM, basically, and of course for your application, right? You might want to offload some of your code to a function as a service. In that case, you're suddenly not responsible for managing operating system. you're not responsible for managing the language version. You're probably still responsible for managing library versions inside of this fast solution, and of course you're responsible for managing your own code, but suddenly your management scope is lessened. I'm not saying actually it is better or worse, because the greater scope you have, the more customization you can do. Sometimes you need to install custom software and use it. Sometimes you don't. And like the more managed scope you have, the more permissions you have, the more customization you can do. But if you can say that I'm staying mainline, I don't need any customization, the idea of reduction might be attractive. And again, automate deployment of everything, including security controls. Identity management. Use strong sign-in mechanism. That means for humans MFA, and very specifically that means application MFA. Remember that SMS and phone numbers are, I won't say they're completely unsecure, but they're way less secure, way easier interrupted, way easier hacked rather than an application. Of course, ideally you will use hardware tokens, but that is an additional layer of complexity, and you might have to, depending on your industry, but usually at least use an application. Use temporary credentials. In no cases you really should use persistent long-term credentials as a last effort, and really you should not use them if at all possible. Store and use secrets securely. There has been a session a bit earlier today by Andrea, so if you have a time machine you can go visit security roadmap session. Otherwise it will be available in a few days on our learning portal. And rely on centralized identity provider. All InterSystems products out of the box support LDAP, ID, and OAuth protocols, so you can configure centralized authentication and authorization with this tool by not writing code, but rather configuration steps. And if you have some more elaborate requirements, you can use Z-Authenticate, which is our mechanism to provide customization access to the authentication layer. Of course, you want to audit and rotate credentials periodically, and do not assign permissions directly to users. Use intermediaries such as groups and attributes. We're going into permission management. So now first we authenticated someone, now permissions. If there is the easy rule of thumb is that you need to know what every permission does in your permission set. If you don't know what a permission does, you can try to remove it, see if it breaks anything, and repeat this process until removing anything else breaks the workflow. Grant least privilege access, and there are two advices here. Default and provide policies are often too permissive, and here where you can encounter them. First of all, you can go to the cloud vendor website, to their blog session, and you can see an official article on a new exciting feature which you want to try, written by basically people who work for this cloud vendor, and it will have a tutorial explaining to you how this feature works, and it will also have steps how to set up it, and usually the permissions there will work for you for sure, because that's their goal, right? But they will not be the least possible permission, so you need to check that. And another area where you can accidentally grant too broad permission sets are cloud managed permissions. Usually you will have you can write either permission directly or pick one from the list provided to you by your cloud vendor of choice. And these permissions are also, I won't say always, but they might be over-provisioned, over-permissioned. So the best way to check is that you need to know each line of your permission, what exactly it allows, and you also need to know that removing this line will result in something not working, because you don't have permission to do that anymore. Of course, and it is a continuous process. You'll notice that even if you forbid, admin access, the permissions have a tendency to try to escalate. Cross-account access. Cross-account access, the worst way to do cross-account access is using long-term credentials. Slightly better cross-account access is using short-term credentials. Both are not recommended. The best way to do cross-account access is to create an identity in account A, an identity in account B, which has a permissions required in account B, and grant access for identity in account A to assume identity to become identity in account B. This is considered best practice. Permission boundaries, since in a cloud environment, you will have your initial identity and there will be a lot of ephemeral identities. So you have a first identity, assume a second one, assume a third one. Permission boundary allows you to get to the first identity and say, sure, it can assume something else, but it must still be within this boundary. In InterSystems products, we have a corresponding feature called privileged routine application, which works slightly different, but for the same purpose, which limits the scope where permission escalation can happen. You can provide a list of class methods and routines which can request an additional permission set on behalf of your user. And as soon as you leave privileged routine or a privileged class method, these permissions disappear. Just a small example here of permission evaluation. So in, for example, AWS, this is what happens when it decides should we allow or deny an action. And this is actually simplified. There are some parts which are cut out, which are more rare, but even that, as you can see, is extremely complex. And depending on your cloud, I think it will be a good advice to be familiar with how permissions are evaluated. Detection is pretty similar between on-prem and the cloud. Log everything. Disk is cheap. Lawsuits are not as cheap. Capture logs, findings, metrics. Ideally, you will manage everything and capture everything in a securitized location. For IRIS, you need to capture at the very least message log, and we also provide API monitor service, which is a REST API, which is open metrics standard, commonly known also as a Prometheus metrics, which is consumable by probably every logging system ever written since 2010 or something. I'm not sure, but it is a very popular standard. If you want to, you can use, of course, your cloud vendor centralized logging location, but most organizations already have something defined. So it is, again, just something to think about. Let's get into the infrastructure protection. And the good and the bad thing of being in a cloud is that all your network now becomes SDN, software-defined network. And you're an API call away from changing the topology. You don't need to plug cables different way to change the topology of your network. You just call an API. So use network layers, control traffic flow, and an advice here is to use logical grouping instead of exact values if possible. What it means? Let's say you have a mirror pair with primary and backup, and you also have ECP servers, and you want to scale ECP servers between 1 and 10 and also grant ECP servers access to the mirror pair, right? Very, very straightforward setup. And how do you want to do that? You can, of course, put them all in one subnet and just say everything within the subnet can talk to each other. that will work, but that will not be very secure. A more secure way, which you will be familiar on-prem, or you can actually do that in the cloud, you can record the IP addresses of every machine and create a firewall rules which say that this IP can talk to these two IP, right? For each ECP, they can talk to two IPs of mirror members or a virtual IP over this particular port. But that creates issues. First of all, what if you want to do 11 ECP servers tomorrow, right? That you need to add a new rule. Second, what if you scale back down to one server or to two ECP servers? What happens to these rules? Should you delete them, or should they just be kind of idle, allowing access to nothing, right? Because these IP addresses are not really, well, they're in part of subnet, but they are not belonging to any particular machine. And in addition to that, you also need to remember that your ECP server should, when you scale back, they need to get the same IP addresses, which is not guaranteed, right? You can just do a dynamic allocation. So in the cloud and in some on-prem actually products, but we saw a lot of on-prem configuration. That's usually not really as easy to do there or at all possible. You can say that your mirror members are virtual machines are called, like, I don't know, some resource group called mirror security group in AWS, and your ECP servers will be called ECP. And you can create a network rule which says that ECP group can talk to mirror group over the port 1972 or whatever you use for your super server port, and that's it. As soon as the new ECP server spins up, it is automatically added to the ECP group, security group, and the same permissions are applied to it. So you don't need to change anything. That's why you want to avoid using IP addresses if you want to use, if you can use logical groupings. It simplifies management. It's way more convenient. Implement inspection-based protection. If you can do that, certainly an additional layer of security. Remember that everything is an SDN. Once again, the most important part, a change of your network is one API call away. I want to give you an example. In AWS, there is a pretty hard limitation where your subnet must be within the same availability zone. And that creates an issue with virtual IP in IRIS, because if you have a virtual IP in IRIS, both mirror members and virtual IP must be in the same subnet. So in AWS, they must be in the same availability zone, which defeats the entire purpose of, highly available configuration. But what you can do instead is that you can route traffic using route tables to a specified network interface. And what we can also do, we can execute an API call which takes the network interface from one node to another, one virtual machine to another. This is a valid API call. Of course, one of the solutions is to place a load balancer before IRIS. That will also work. But another solution which you can use and which we actually using very extensively in Health Connect Cloud is that we are just taking the ENI itself and we are moving it to whatever is currently primary, because there is a callback when an instance becomes primary where we can execute whatever we want. And what we want is what we want for a primary to grab a network interface which holds the virtual IP for the particular mirror member. So this is just one example of taking advantage of being on software-defined networks. Protecting compute. Of course, you'll want to do vulnerability management. That's pretty much the same as on-prem. Provision compute from hardened images and try to use immutable references. If your supply chain requires you installing software ABC version 1.2, what it is today can can differ from what it is tomorrow. Someone can swap whatever is version 1.2, even if you pin the version. But if you're saying that you want to install the software at the hash ABCD, right? There is no way to change that. The attacker, of course, can create a new version 1.2, but the hash will change. And since you're using immutable reference, which is, for example, a hash, you will not be affected. Well, I mean, you would be, right? Your build will fail because there is nowhere you cannot grab this software with this hash, but failing a build is way better than introducing a new vulnerability into your software. Reduce manual management and validate software integrity. Getting a PGPK is like 1 or 2 lines of code, and it can save you a lot of headache if some part of your supply chain becomes hacked. Since, sorry, do you have a question?
Yeah.
Sure.
So when you say VIP, right?
Virtual IP.
Yeah, virtual IP, but InterSystems term for a VIP is not technically accurate, right? Because it's an IP that's an alias on the server, right? Because in our organization, we actually use VIPs that are serviced by load balancers, right?
That will also work, yes.
That's how we, you know, like if I say the word VIP and I'm on a meeting with my network team, they go up in arms because, you know, they're thinking of talking about their Citrix or whatever load balancers they use, you know, products, you know, because we don't use in my organization the quote-unquote VIP, what you call VIP, is the service, but I like to call it service IP because, you know, it up, it down between the system, it's really an alias IP, right?
Sure.
So that will help with, you know, because we have high availability going across different data centers, so we have different subnets and everything, so using a load balancer really helps us. I think that also adds us an additional layer of security because, you know, we can set up rules going through our organization that virtualizes that IP address that doesn't even hit our servers, so we can protect us. Anyway, I just wanted to share that.
Sure, load balancers are also supported and accepted way of doing that. This was just an example. If you want to, we can discuss specifics after the session. I also have a published article on InterSystems developer community explaining the approach of getting VIP software-defined virtual IP in all 3 major clouds, Azure, GCP, and AWS, if anyone is interested. Thank you. Data protection. Now we are getting to the more IRIS bits. So your data protection starts from data classification. You need to understand what data is just merely private and which data is critical, usually personal data. And again, this part is offloaded to whatever regulations you're operating under, especially if you're in a healthcare business. Apply data protection controls based on data sensitivity, and IRIS provides you a variety of controls which you can use. You can split your data by the database. You can use SQL security. In addition to SQL security, we have, as a part of, not in addition, as a part of SQL security, we have column and row level security, which you can also take advantage of. You can use resources and roles to gate access to your data, well, more resources specifically. Once again, you have access to privileged routines application and, of course, encryption. And don't forget to define data lifecycle management because attackers cannot steal the data which you have already deleted because you don't need it. Protecting data at rest is encryption once again, automate and enforce it, and also enforce access control. Even if the data is encrypted, if anyone can get access to the API which returns it, that doesn't help you very much. Protecting data in transit, you want to do certificate management, automate certificate rotation. Check out the session Encryption in Transit in InterSystems IRIS by Jonathan Suho, where he discussed this in greater detail. One additional advice here is authenticate network communication, including communication in your private network. Also, if you're doing direct connect or other layer 2 layer 1, layer 2 connectivity. You know, you can just have a cable to the cloud vendor. Remember that it is usually by itself unencrypted. It's just an additional cable, just dedicated to you for sure, but it will not be by default by itself encrypted. You will need to run a VPN or encrypt traffic in some other way, even over a direct connection. Incident response, very similar between cloud and on-prem. Detect, analyze, contain, eradicate, recover, have a knowledge base which you populate from past incidents, pretty similar. And application security, again, automate building and testing. Remember that your building pipeline naturally contains secrets, especially if your building pipeline has some like pushes artifacts to the cloud. So you want to split the access to your build and build pipeline, and especially to the secrets. Most build systems currently have special support for secret data. Don't forget to use it. And some final comments. Provide security at every level. Remember that security is a multiplication game and not a sum game. If one of your security layers is, let's say, underperforming, the entire security can collapse. It doesn't compensate, right? The lack of security of one layer can only in a very limited way compensate for presence of security on one layer. Doesn't compensate the lack of security on the different layers of your stack. Remember your industry-specific regulations. Check twice if you're in health. Check 3 times if you're an international company. Automate everything and test your security. For example, at Cloud Delivery Team, we do penetration testing 2 times a year, 1 time external, 1 time internal. Have game days, even if you are part of a great team, but if the first time you ever encounter the reaction to a security incident is when it actually happens, of course you will spend a lot of time just figuring things out. But if you regularly have game days where you try the same thing in a safe and secure manner without, actual security incident, and you provide and you produce runbooks, you produce knowledge base, you produce familiarity with process. If the unfortunate thing happens, your team, you will be prepared. And finally, before we move to questions, remember that every dollar and every hour you spend on security makes it exponentially harder for your attacker to be successful. InterSystems is a secure platform, and in addition to that, by default, it provides a variety of tools which I try to outline, describe in this session, and by using them, you can make your application extremely secure regardless of where you host it. But if you host in a cloud, you can integrate with the cloud security tools to get great security. And with that, let's, I think, move to the Q&A. We have just 10 minutes. Yes?
In regards to the IRIS cloud adapter for interoperability, your sound productions right directly to I'll use AWS for this S3 bucket. One of the things that I guess I'm complaining, so obvious, but it's always kind of bothered me that we have to store those credentials in plain text and on a file on the operating system, rather than internal IRIS as like an interoperability credential. Is there any thought from any team to change that?
It supports instant. So I will repeat the question. And for our cloud adapters, you need to provide a path to a file which contains credentials. And the answer here is that it does support, most of our cloud providers does support instance profiles. So if you're running in the cloud and your virtual machine has an associated instance profile, and this instance profile, which is a role, right, will have permissions to access S3 bucket, that will be used instead. So yeah, you can use this cloud adapters, at least as free cloud adapter, without providing any credentials at all, because they are part of the virtual machine identity. You can say that this virtual machine has this permission set, and everything inside of it will also have the same permissions, including, in particular, cloud adapter provided by InterSystems. Sure. It is actually, I don't think it's a part of our documentation because it is implicit part of the cloud APIs which we are using. Yes?
Yes, can you go over that solution for fit within the cloud environment with the subnet?
Sure.
Let's say it was
Yeah, sure. So it is done in two parts. First of all, we create a route in a route table which routes either one of the IPs which we want to use as a VIP to a specific network interface, which is an additional custom network interface. In AWS, it's called ENI, Elastic Network Interface. And there is a call which, okay, so first, IRIS fails over, right? And we are getting in ZMirror routine callback. And this ZMirror routine callback, when we notify become primary specifically, calls AWS API using actually instance profile. We are using the same mechanism here, and reassigns ENI to a current node, to a current virtual machine. Yeah, this is perfectly valid. And since the routing is from the IP to the specific ENI, it goes to the new primary, which is useful. Why we went this way? The default way is to use load balancers. We went this way because in Health Connect Cloud, most of our customers are using HL7. And if they're using HL7, they are using TCP connections. And at least in AWS, this is not a limitation in GCP and Azure, but in AWS, if you're using TCP with load balancer, you must use network load balancer, that's one. And second, you're limited to 50 ports. And it's not even a range, it's actually each listener port must be defined in a different way. And we have customers with like hundreds and hundreds of ports on one node because it's hundreds of TCP connections. So that managing that was complicated. You need to create several load balancers, and you need to somehow know which port is on which load balancer, which was very complicated. So for us, the solution was to use the virtual IP defined as this way.
Now, when setting that up, is that a manual setup, or is that part of the configuration page, the kernel that exists, setting up mirror? Is that something I'll need to write code to do?
We provide, so if you're using Health Connect Cloud, it will be available to you out of a box. If you use IRIS Cloud Managed Service, it will be provided to you out of a box. If you are hosting on-prem, you're hosting yourself, you can use the community article. You can search VIP in AWS InterSystems, and that will be the first result, which provides the code to do that.
Now, so if I apply that code, does the system support that, or is that what
you can write to me, you can write a comment on the article, but we have been running it in production for quite a while, and it's the API is not really changing. So
you're actually moving an IP from one subnet
network interface. It kind of yes.
To a EC2 server in a different subnet that's not
Yes.
part of that ENI, so it doesn't compute all over itself?
No, that's absolutely no problems. This is a valid action from AWS perspective, no problems. Yes?
So you're saying if you use it in the cloud, you have to assign every port that the
Sorry, could you repeat?
because on-prem, what I would go down is we could just say TCP will be any port, right? But I guess that's, you're talking about the cloud, and you want to narrow it down to the portion, right?
Oh yeah, usually, well, I mean, you can of course allow any port if you want to, and all ports altogether, but the preferred and more secure way is to allow either specific ports which you know will be in use or port ranges which you allocate beforehand. Well, in that case, I think I thank you for your attention.